So hello everyone, welcome to this new session. So till now we have solved all the problems related to partial fractions, right? And in my one of the sessions I have explained and kept the differential equation concept, right? So this is our last concept, and we are going to solve two important problems related to this, okay? So that you can get an idea about this problem and you can solve this, okay? So this is your differential equation in this case, okay? See, we don't have d by dx terms. In place of that we have u of n plus 2, u of n plus 1 and u of n, okay? So we have written some standard left shifting property rules, right, for u of n plus 2, u of n plus 1 and all, right? That only we are going to apply it here, and we are going to substitute and we are going to solve it, okay? And they have given some standard fixed values for u0 and u1, that is u0 equal to 0 and u1 equal to 1, okay? So now we will solve this as we have discussed the procedure, right? The first thing in procedure, first thing we need to take is we need to take the z transform on both sides, okay? So let's take the z transform on both sides. U of n plus 1 plus 3 into u of n equal to z transform of 3 power n, okay? So again apply the linearity property and split the z transform, so it becomes z transform of u of n plus 2 plus, take this 4 outside, z transform of u of n plus 1 plus 3, take outside, z transform of u of n is equal to z transform of 3 power n, okay? So now apply there are the values, we need to apply the z transform. So the z transform of u of n plus 2, we have discussed it, right? What it is? It is z square into u of z minus u naught minus u1 z inverse, right? That this is the z transform of u of n plus 2, which we have discussed in now one of the sessions, okay? You need to be knowing this. Plus again the z transform of u of n plus 1 equal to 4 into z into u of z minus u naught plus 3 into, it's the simple definition, that is z transform of u of n is equal to u of z is equal to z transform of 3 power n, that is a power n, that is, we know that it is z by z minus a, right? So in place of a there is 3, so write it as z by z minus 3. Okay, so now here we have u0, right, and also we have u1, and we have some of the fixed values given in the question, right? So that substitute that, by substituting we get u of z, the value of u0 is 0 minus the value of u1 is 1, so I'll write it directly z inverse since u1 is 1 plus 4z into u of z minus 0 plus 3 into u of z equal to z by z minus 3, okay? So now only further simplification is left out, okay? Z square into u of z minus z inverse plus 4z into u of z plus 3 into u of z equal to z by z minus 3. Okay, so now here multiply z square to both the terms, so it becomes z square into u of z minus z square z inverse plus 4z into u of z plus 3 into u of z equal to z by z minus 3. Okay, so now what is this z square into z inverse? So if you bring the z inverse to the denominator, it becomes z power 1, right? And z square divided by z power 1 means z will get cancelled, so the remaining term here is minus z, right? So let's write it, z square into z inverse is equal to minus z if we simplify it, okay? Plus 4z into u of z plus 3 into u of z equal to z by z minus 3. So now the next, in the procedure, the next step here we can see that in these three terms there is a common term, that is u of z. So we need to write it separately, right? I've told you, right? Write the u of z separately and write the remaining terms, that is z square plus 4z plus 3, and we have another one more term remaining, that is minus z, equal to z by z minus 3, right? So bring this minus z to the another side. As per the procedure I am following the problem, at last we need to get u of z is equal to some term, right? So that's why I am just doing this. Okay, you need to be knowing this here. See, in these three terms u of z is common. I have taken it outside. I have written the remaining terms, and here the z is left out, so I have written it z minus z. So now if you bring this minus z to another side, it becomes plus z. Okay, so now u of z is equal to, means we need to bring u of z to one side and all the other terms to another side. Okay, it is equal to z by z minus 3 plus z into this it's of the quadratic form, right? So in order to bring it to the partial fraction form, we need to use the quadratic formula, that is so by using the quadratic formula for this term, we get the two roots, that is minus 1 and minus 3. That is, here I have substituted the value of b minus b plus or minus b square, that is 16. 4 square is 16, 4 into 3 into 1, so 12 divided by 2 into 1. The value of a is 1, right? So we get minus 4 plus or minus 16 minus 12 is 4. Square root of 4 is 2. Minus 4 plus 2 by 2 or minus 4 minus 2 by 2, that is minus 2 by 2 comma minus 6 by 2. We get the two roots, that is minus 1 and minus 3. So again instead of this, write it as 1 by z plus 1, since the root is minus 1, right, into z plus 3. I have written 1 by because I have taken this to another side, right? So this gets divided. Okay, so this term remains as it is. Instead of writing it as divided by this term, I have written it separately, 1 by. Okay, so now take the LCM for all these terms. Okay, that is u of z is equal to so write it z by z minus 3 into z plus 1 to z plus 3 plus z by z plus 1 into z plus 3. This we have got by taking the LCM. Okay, so now in order to make the common denominator equal, we need to write it as z square minus 2z, because here we don't have a z minus 3, right? If we don't have here z minus 3, so we need to write z into z minus 3. So the final answer which we get here is z square minus 2z. Okay, after taking the LCM. So now we have gotten finally our aim was to get the u of z. Okay, so now we have got u of z. So now here we need to apply the partial fraction as we have done in our few past problems. The same thing here, we need to apply the partial fraction and need to find the values for a, b and c, and at the end we will get the inverse z transform of this answer. So that is your solution for this equation. Okay, so now let's solve this. So I have written it in the form of partial fraction, that is az into z plus 3 plus bz into z minus 3 plus cz into z plus 1. So name it as equation star. So again the same thing, the procedure remains the same, that is we need to cancel out the denominator. For that we need to take the LCM on the other side, z plus 3, z minus 3, z plus 1. So the remaining terms are az into, here what are the terms missing, z minus 3 and z plus 1, right, plus bz into z plus 3, z plus 1 plus cz into z plus 3 and z minus 3, since we have z plus 1. Okay, so cancel out the denominator. So the remaining terms are az into z minus 3, z plus 1 plus bz into z plus 3, z plus 1 plus cz into z plus 3 into z minus 3. Okay, so now here again take the z common on both sides and cancel it out. Okay, so yeah, I have done it. So in this term I have taken z common, and here also I have taken z common. This is the remaining term. Cancel it. So name this equation as equation 1. So here we can see that for A and B we can find the values. For C we need to use the coefficient. We need to compare the coefficients. Okay. So in order to find the value of A, we have z plus 3 common in B and C. So we need to put the value of z as minus 3, right? Okay. So first put the value of z equal to minus 3. So I'll directly write it. So minus z equal to minus 3. So minus 3 minus 2 equal to, these two terms will become 0, right? So A into minus 3 into minus 3 plus 1. So while we solve this, we get minus 3 in minus 2 is minus 5. A into minus 3 is minus 6. Minus 3 plus 1 is minus 2. Minus 5 equal to A into 12. Therefore A equal to minus 5 by 12. Okay. So now similarly find the value of B. So in order to find the value of B, here the common term here is minus 3, z minus 3. So you need to put the value of z as 3 to make these two terms 0. So put the z equal to 3. So 3 minus 2 equal to, so the term which we are finding here is B, right? So these two terms will become 0. Only this term we need to write it. So B into the value of z is 3 plus 3 into 3 plus 1. So 3 minus 2 is 1. B into 6 into 4. 3 plus 3 is 6 and 3 plus 1 is 4. 1 is equal to B into 24. So B is equal to 1 by 24. Okay. So now we have found the values for A, B and C. So now in order to get the value of A and B, we have found the values for A and B, sorry. So in order to get the value of C, here we know that the highest degree here is, by multiplying these two terms we get the highest degree as z square. Okay. So now let's rewrite this equation in by multiplying these two terms in all the cases. Okay. And we need to compare this coefficient. So I've rewritten this equation. We can see that by multiplying these two terms, so we get these three terms. Okay. So now here we need to compare the coefficients. Here there is no z square, so this becomes 0 is equal to. So here in all the cases we have z square, right? So we can write it as A plus B plus C. Okay. So now substitute the values for A and B, that is 0 is equal to, the value of A which we got is minus 5 by 12 plus the value of B is 1 by 24 plus C. Okay. So bring this C to one side. So bring this C to other side, so it becomes minus C, and take the LCM. Okay. So 24 into 5, that is 24 5s are 25 is 104. So it is minus 120 plus 12 divided by 24 into 12. 24 10s are 240 and 24 10s are 240 and 24 2s are 48. So we get 240 plus 48, that is 288. Minus C is equal to minus 120 plus 12, that is equal to minus 108 by 288. Okay. So now how we can in which table it is divisible. Okay. So okay, let's try with two table itself. So this is 54, 144, 27 and this is 72. So 27 and 72. So yeah, it's divisible by 3. So 9 3s are and 9 8s are. So the final value of C which we got is C is equal to minus 3 by 8. Okay, by simplifying this we got the value for C. So now we got the values for A, B and C. The similar thing we need to put them in equation star. So here I have substituted the value for A, B and C. So here it is plus 3 by 8, okay, it's not minus 3 by 8 since we have your minus right here. So yeah, sometimes mistake will happen. So yeah, we need to be very careful by solving the problems. Okay, so here it is minus 3 by 8, so this minus, so it becomes plus 3 by 8. Okay, yeah, so I have substituted the value of A, B and C. The same thing we need to apply the Z transform, inverse Z transform, Z by Z plus 3 plus 1 by 24 Z inverse of Z by Z minus 3 plus 3 by 8 Z inverse of Z by Z plus 1. Okay, so minus 5 by 12 into, here the value of A is minus 3, right, minus 3 power n plus 1 by 24, the value of A is 3 power n plus 3 by 8 into the value of A here is minus 1 power n. So this is your required answer. Okay, so this is a very lengthy problem and we need to be very careful in each steps, okay, of solving the differential equation. Okay, so I am going to solve one more problem which is very lengthy. Okay, so okay, we'll get to the next question. Okay, so yeah, this is your second question. U of n plus 2 plus 6 times U of n plus 1 plus 9 times U of n equal to 2 power n. So the same thing again, we need to take Z transform of both sides, apply the linearity property on the left hand side. Z transform of U of n plus 2 plus 6, take outside Z transform of U of n plus 1 plus 9 into Z transform of U of n equal to Z transform of 2 power n, that is Z by Z minus 2, right? So now apply the Z transform of this, that is Z square into U of Z minus U naught minus U1 Z inverse plus 6 into Z transform of U of n plus 1, that is Z into U of Z minus U naught plus 9 into Z transform of U of n is U of Z equal to Z by Z minus 2. Okay, so we know that here the given condition is U naught equal to U1 equal to 0. So the value of both U naught and U1 are 0. Okay, so now we can directly skip the U naught and U1 terms since all the U naught and U1 are 0, right? So we can directly write it as Z square into U of Z plus 6Z into U of Z plus 9 into U of Z equal to Z by Z minus 2. Since both are 0, right? So I have just neglected the terms, that's it. Okay, so now bring U of Z to one side, write the remaining terms plus 6Z plus 9 equal to Z by Z minus 2. Okay, so now this is again of the quadratic form, find its roots. So apply the quadratic formula here at the side. So minus b plus or minus square root of b square minus 4ac divided by 2a, right? So here the value of b is 2, so minus 6 plus or minus square root of 6 square 36 minus 4 into a, 4 into 1 is 4, 9s are 36 divided by 2, so it is directly equal to 6 plus or minus 0 by 2. So 6 by minus 6 by 2 is repeating, right, twice, plus 0 minus 0, so the answer is minus 3 comma minus 3. Okay, so these are the two roots. So now write this as U of Z into, since it is minus 3, Z plus 3 into Z plus 3 equal to Z by Z minus 2. So now bring this Z plus 3 to other side, so it becomes Z by Z minus 2 into 1 by Z plus 3 into Z plus 3. Okay, so the final U of Z which we get is Z into 1 is Z divided by Z minus 2. Z plus 3 is repeated twice, right? We can write it as Z plus 3 whole square, right? So our first half of the problem is done, that is we have found the U of Z. Okay, so now again the same procedure of partial fractions. We have solved so many problems till now. You need to be knowing all the steps very clearly. Okay, so now I am just going to solve it in a very quick manner. Okay, yeah, so I have substituted it in form of partial fraction. az into z minus 2 plus bz into z minus 3. So z plus 3, since there is a 1 power, so we need to multiply it by z. So here now we need to multiply it by az, right? So but it's of the form z plus 3 the whole square, so it is also equal to minus of minus 3. Here the value of a is 3, so we can write it as minus 3z. That's all I've written it here. See, I've written minus first, right? Minus c into 3z. Okay, so now again the same thing, we need to take the LCM. Z minus 2 z plus 3 whole square, az into z minus 2 is there, z plus 3 whole square is missing, write it, plus bz into z plus 3 is there, z minus 2 and another z plus 3 is missing, write it, minus 3cz, right? Z plus 3 the whole square is there, z minus 2 is missing. Okay, so now cancel the denominator and write the remaining terms. That is equal to z into az into z plus 3 whole square plus bz into z minus 2 z minus z plus 3 minus 3cz into z minus 2. Okay, so now here take z common. So here okay, I'll directly take okay, I'll write that step. This z keep it as it is and take z common here in the right hand side. Z plus 3 whole square, b into z minus 2 z plus 3 minus 3c into z minus 2. Okay, now cancel the z, so the remaining equation we get is a into z plus 3 whole square, b into z minus 2 z plus 3 minus 3c into z minus 2. So this is your equation 1. Okay, so here again we can find the values. We can see that we can find the values for a and c, right? So in order to find the value of a, we have these two terms common, and for c we have these two terms common, but for b we don't have any terms common. For that we need to apply the coefficient of the higher degree, that is square. Okay, for that we need to split this by using the identity. Okay, so first only we'll write it. First only we'll write the new equation in order to find the b. In order to find b, we need to compare the coefficients. Okay, so first only we'll write it. After that we'll directly find the value of b. Okay, so I have splitted the terms, that is z plus 3 the whole square, right? That is equal to z square plus 6z plus 9, and b into z minus 2 into z plus 3, right? I've just multiplied the terms and I've got this term, and this term remains as it is. Okay, so now in equation 1 we need to put the value of z equal to 2 in order to find the value of a, right? Okay, so now let's do it. So a is equal to a into the value of z is 2 plus 3 whole square. B and c is automatically 0, right? So yeah, 2 plus 3 is 5, 5 square is 25. Therefore the value of a which we get is 1 by 25. Similarly, put the value of z equal to minus 3. Minus 3, right? Yeah, see here, in order to find the value of c, it is z plus 3, so we need to put it as minus 3 in both sides. Okay, so this becomes 1 equal to c, right? So a and b will automatically become 0. The remaining term is minus 3c into minus 3 minus 2 is equal to minus 3c into minus 3 minus 2 is minus 5. Minus 3 into minus 5 is 15. So the required value of c is 1 by 15. Okay, so now we need to compare the coefficients of z square in equation 2 in order to find the value of b. Okay, yeah, see the equation 2, where and all z square is there. Here in the left hand side there is no z square, so this is 0. Here there is z square, the coefficient is a. Z square, the coefficient is b. Here there is no z square. Okay, 0 is equal to the value of a which we have found is 1 by 25, right, plus b. So bring this 1 by 25 to other side, so we get the value of b as minus 1 by 25, right? So now again the same thing we need to substitute in equation star. So yeah, I have substituted the value of a, b and c. So apply the inverse Z transform. 1 by 25 minus 1 by 25 z by z plus 3 z inverse plus 1 by 15 z inverse of minus 3z by z plus 3 whole square. So it's equal to 1 by 25 into the value of a is 2 power n minus 1 by 25. Here the value of a is minus 3, right, power n, plus 1 by 15 into, this is of the form az divided by z minus a whole square, where the value of a here is minus 3, right? So yeah, we can write it as the z inverse of az by z minus a whole square is equal to n square into a power n. So in place of a it is minus 3, so n square into minus 3 power n. So this is your the final answer of this module. So this completes your Z transforms. So hope you like this module. So please let me know in the comments that how was this module? Tough, easy, manageable? So can you score in this module? Please let me know in the comments, okay? So this completes your module, Z transforms. So I guess we have taken similarly 10 videos for this as well. So in total 2 modules have taken 20 videos, right? Okay, now in the upcoming sessions we are going to give the solutions of the model question papers, okay? So there are nearly 5 to 6 videos of model question papers coming ahead of you, okay? This SEM's released model question paper, our teacher has circulated it, okay? So the solutions for that also would be provided for you in form of video lectures, okay? So in the upcoming 2 days you are going to get it, okay? So that's all. This completes the module. If you have any doubts, please comment down, and please like, share, subscribe to your close ones, okay? And please share it, and please try to understand this subject, because this subject is very, very important. This is the first subject, that is 301, right? You need to be careful about this subject, okay? So yeah, if there are any doubts, please let me know in the comments. And after the solution of model question papers, after that I am going to continue with the next module, that is infinite Fourier transforms, okay? That's also a very interesting module. We are going to get to know about some more concepts related to the Fourier series, okay? So yeah, that's all. So in the upcoming sessions you are going to get the model question paper solutions. So please refer them, please solve them, please practice them without observing the videos. I'm going to give the solutions, I'm going to solve it, and after that please observe it and try to do it without any help, okay? So that you will get to know about the concept. So that's all. Hope you like this. Thank you.